Hello, so in this video we're going to look at solving logarithmic equations, and there is one very important thing that you need to remember when you are dealing with logarithms, is that whenever you have a log function, f of x is equal to log base a of x, whatever a is, it's only defined for x greater than 0. So whatever you have, whatever your input is, it has to be greater than 0. And this is very obvious when you look at the graph. This is the y-axis. This is x is equal to 0. The log function, this one, is only defined if x is greater than 0. And same here. It's only defined for x greater than 0. For x greater than 0. So that is something you want to keep in mind. If it's 0 or less, then the logarithm of that is not defined. So that is something you want to keep in mind. So here, we'll immediately look at all of our log functions that have x in it. And so before I begin, a few comments is that in some of the videos, if you check the answer from your textbook and my answer, it may not be matching because I may have simplified less or simplified more. So please feel free to cross-check and simplify and do the comparison. And if there's any mistake, you are more than welcome to leave a comment so I can correct it at a later stage. So here's how we are going to approach these questions. Wherever we see log function with x in it, we're going to say that this x has to be bigger than 0. So, and I'm going to only be solving what a and d for all of these questions. So b and c you can try on your own. So a has to be greater than 0. For a, in this function, a has to be greater than 0. These I don't really care because the inputs are already bigger than 0. So now we can use the laws of logarithm to combine the left-hand side. Log base 5, and then these we can just multiply. Equal to log base 5, 30. And there's two ways to think about it. You can say that, hey, I have the same base, so these values must be equal. 3x must be equal to 30, x is equal to 10, and 10 is greater than 0. So we're fine. But another way to think about it is that if these two things are equal, then if I raise 5 to these two things, then it still must be equal. And I'm choosing 5 because that is our base. And here, now we've done this over in previous videos. This is just 3x, right? And this side is just going to be 30. And you still get x is equal to 10. So that is how you do 1a. Now when we go to 1d, I'm going to be doing a and d. We're going to say that this input, x minus 4, has to be greater than 0. That is important. And therefore, x has to be greater than 4. If x minus 4 is greater than 0, we are allowed to add or subtract, and the inequality is not affected. So if x minus 4 is bigger than 0, then that means x is bigger than 4. Sorry. So we have that to take care of for question D. So now, the left-hand side, we can just keep as it is, but we can simplify the right-hand side. So this is going to be log base 10, 5 squared. So as I previously mentioned, we always want no number in front. So 5 squared is going to be 25 plus log base 10, 2. And we can actually simplify this further because 25 times 2, this is going to be 50. And now we can just say, hey, x minus 4 is equal to 50 using the same method that I showed you in 1a. You can raise both, you can keep the base as 10 and then put both sides as your exponent and get to the fact that x minus 4 is 50. So x is going to be 54. And 54 is indeed bigger than 4. So there you have it. So 1a is 10, 1d is 54. So moving on to question 2. So question 2a, we want this. 2x plus 9, we want it to be bigger than 0 because that's inside our log function. So 2x has to be bigger than negative 9. We can subtract 9 on both sides. And therefore, my x has to be bigger than negative 9 by 2. So my x has to be bigger than negative 4.5. So a very important thing about inequalities is that if I had negative 2x greater than negative 9, then when I divide both sides by negative 2, I have to flip the inequality. So if I am dividing by a negative number, I have to flip the inequality. And that is a very important thing to remember when we are dealing with logarithmic inequalities, which we will. So 2x is greater than negative 9. And because we're dividing both sides by positive 2, we can keep the direction. The inequality does not change. So negative 9 by 2. So x is bigger than negative 4.5. And now we can start solving this question. So log base 10, 2x plus 9, we're going to get divided by 5 because there's a subtraction here. And on the right-hand side, we're going to get log base 10 of 10 because 1 is equivalent to log base 10 of 10. And we can simplify this further. We can say that, hey, if my base is 10 and these are my exponents because they're equal, then I sort of get to I can deduce that 2x plus 9 divided by 5 is 10. 2x plus 9 is 50. 2x is equal to 41, and x is 41 by 2. And 41 by 2, and let me just cross-check my answers as well, but 41 by 2 is greater than negative 4.5. So that is your answer. And for 2D, well, I want to look, if I look here, then this tells me that 2x minus 3 has to be bigger than 0. This tells me that 3 minus 2x has to be bigger than 0. So 2x has to be bigger than 3, and x has to be bigger than 3 over 2. And then this tells me that 2x, or let's say minus 2x, is greater than negative 3, right? Then when I divide by negative 2 on both sides, I have to flip the inequality. So I get 3 by 2. So x is bigger than 3 by 2, and x is less than 3 by 2. So there is no such number that is both bigger than 1.5 and less than 1.5, right? One number cannot be bigger than 1.5 and less than 1.5 at the same time. So the only number that we actually can think of as a valid answer is x is equal to 3 by 2, right? And you will see that if you substitute x is equal to 3 by 2 here, this goes to 0 and this goes to 0, and that is not allowed. So actually, for part D, there is no solution. Because a number cannot be simultaneously bigger than 1.5 and less than 1.5. So that is not possible. So the only possible answer that we can think of is 1.5. So when we try to put in 1.5, then we see that log 5 and we have 0 here. But we are not allowed to, the input for a log function must be bigger than 0. So there is no solution to part D. Let's go to question 3. So here, this tells me, the first part tells me x must be bigger than 0. The second part tells me that x minus 1 must be bigger than 0 or x must be bigger than 1. And if x is bigger than 1, it's definitely bigger than 0. So we don't really need to care about this part. So we need x bigger than 1 for our final answer. And now we can just go simplify as we did before. So log base 2, x plus x minus 1. So we can multiply, equal to log base 2, 20. And because we have the same base, we can equate whatever we have here. So x minus 1 equal to 20. X squared minus x minus 20 equal to 0. And we can solve by factorization. So I believe this is a skill that you have learned in grade 10. But if not, you can use your sum and product method. You can use the quadratic formula, but I'm going to use factoring. And we will go through this in more detail when we go into the chapter for quadratic functions. But I feel that this is something that has been covered in grade 10. So I'm just going to factor this very quickly. But when you factor things out, you will realize that this is x minus 5, x plus 4 equal to 0. That is 3a. Again, if you check, x times x is x squared plus 4x, minus x is minus x, and then you have minus 20. So x is 5 and x is negative 4. When you put this part to be 0, then you get x is equal to 5. When you put this part to be 0, you get x is negative 4. So we said x is bigger than 1. If x is bigger than 1, this is not a solution. So we only have one solution, that is x is equal to 5 for 3a. And for 3d, we know that 3 minus 10x must be bigger than 0. And we have another log function here. So x must be bigger than 0. And we can see that minus 10x bigger than negative 3. And we can flip the inequality when we divide by 10. So minus 10x is bigger than negative 3, and then we can divide by negative 10 on both sides. We have to flip the inequality. So you have 3 by 10, which is 0.3. So x is bigger than 0 and less than 0.3. So that is something that we want to remember. Bigger than 0. So I can remove this here. And now we can solve our inequality. So 3, I can write it as log base. And because our base is 2, then I'll write it as log base 2 of 8. Because 8 is 2 cubed. Plus log base 2 of x squared. I'm taking this to the front. And I can simplify this. I can write it as 8x squared actually. And we have log base 2, 3 minus 10x. So when you solve it, you will get 8x squared is equal to 3 minus 10x. And the method of solving this, we have just been discussing for the past 2 or 3 videos. So 8x squared plus 10x minus 3 equal to 0. And we have to solve this quadratic equation. So if you have this, if you have ax squared plus bx plus c equal to 0, then x is given by minus b plus or minus the square root of b squared minus 4ac divided by 2a. So this is the quadratic formula that I hope you have learned in grade 10. But we are going to be using this formula. And when you apply the formula, so b is 10. So minus b is minus 10 plus or minus the square root of 10 squared is 100 minus 4 times a is 8 times c is negative 3 times negative 3. And when you simplify this, 100 minus 4 times 8 times negative 3, you get 196. And square root of 196 is equal to 14. And all of this is divided by 2a. 2 times 8 is 16. So you have x is equal to negative 24 by 16, or x is equal to 4 by 16 when you solve for plus or minus. So your one answer is going to be minus 10 plus 14 by 16, and your other answer is going to be minus 10 minus 14 by 16. So this tells me that x is going to be 4 over 16, that is 1 over 4, and this tells me that x is going to be minus 24 over 16, that is minus 3 over 2. But remember, we said that our x is bigger than 0, so this negative value is not a solution. And therefore, our only solution is 1 over 4. And 1 over 4 is 0.25, so it is actually less than 0.3. So x is 1 over 4 is your solution. And let me just check. It should be 1 over 4, yes. So that is your only solution. Negative 3 over 2 we reject because x has to be bigger than 0 for this part to be defined. And the only solution is 1 over 4, which is less than 0.3. So now, again, x has to be bigger than 0. We only consider positive bases, right? So x has to be bigger than 0. That is something to remember about logarithms. Your input has to be positive and your base has to be positive. And now we can just simplify like we did. So we have log base x, 40 divided by 5 is 8 is equal to 1. So x to the power 1 has to be 8. So x has to be 8 and 8 is greater than 0. So that is for A. And for D is the same thing. X has to be bigger than 0 because it's in the base. So log base x 32 squared is log base. I'm putting the square here. I can write 3 as log base x squared, right? Because you can bring the 2 front, and log base x of x is just x cubed, x cubed. And this will simplify to just 3 plus log base x 4 squared, which is 16. And now I can simplify. I can write this as log base x 32 squared is equal to log base x 16x cubed. And I can equate. I can say that 32 squared is equal to 16x cubed. And 32 squared divided by 16, so I can actually write it as 16 squared times 2 squared, right? 32 is 16 times 2, and then 16 times 2 bracket squared is 16 squared times 2 squared divided by 16. So these cancel out, and I get 16 times 4, that is 64, is equal to x cubed. And therefore, you're going to get x is equal to 4. When you use your you can use your calculator, or you can just remember that 64 is 4 cubed. So for 4D, your answer is 4. And A, B, and C, I leave you to try on your own because I think it's good practice. So 5A, now we have to remember that because x is here, x has to be bigger than 0. That is the thing to remember. Now, this looks to me like a quadratic equation. Sorry, so for here, this x has to be bigger than 0, right? So this looks to me like a quadratic equation. Why? Because if I say that log base 2 of x is equal to u, then I have u squared minus 8u plus 15 equal to 0. And now, I can solve this. I can actually factorize for u. And u, I believe, minus 5 and minus 3. U times u is u squared, minus 3u minus 5u minus, that is minus 8u plus 15 is equal to 0. So u is equal to 5 or u is equal to 3. And u is just log base 2 of x is equal to 5 or log base 2 of x is equal to 3. So therefore, x is equal to 5 squared, 2 to the power 5, or x is equal to 2 to the power 3. 2 to the power 3 has to equal to x, or 2 to the power 5 has to equal to x. So x is equal to 32, or x is equal to 8. So that is the answer for 5A. For 5D, again, x has to be bigger than 0 because x is inside your log function. And if x is bigger than 0, then x squared is definitely bigger than 0. So that's something we don't really have to worry about. And again, if I say that my log x is bigger than 0, log base 2 of x is equal to u, then I have 4u squared minus, and I can bring this square to the front, right? Minus 4u. So this I can multiply by 2 here, and then log base 2 of x is just u. So 2 times 2 will give me 4u is equal to 3. So minus 3 equal to 0. So this is the quadratic equation, and you can solve this using the quadratic formula. U is equal to minus of minus 4 plus or minus the square root of 16 minus 4 times negative 3. So minus of minus 48. So when you simplify, you get 64, and the square root of 64 is just 8. All over 2 times 4. That is going to give me 8 as well. So u is actually 12 by 8, or I believe minus 4 by 8. So therefore, u is equal to 3 by 2, or minus 1 by 2. And remember, u is equal to log base 2 of x equal to 3 by 2. So x is going to be 2 to the power 3 by 2. 2 to the power 3 by 2 must give me x, or log base 2x must be equal to 1 by 2. So that is 2 to the power negative 1 by 2 must be equal to x. And if I have to write this in more simplified form, this is 2 root 2. I think that is what the textbook writes this as. And this is x is equal to 1 by root 2. And if you rationalize this, you get root 2 by 2. So 2 times root 2 and root 2 by 2 are your two answers to 5D. Now let's solve the simultaneous equations. So from the second equation, and I'll try to solve all of them because these are slightly important. From the second equation, we know that x must be bigger than 0, y must be bigger than 0. That is a requirement that we have. So we can only consider positive values because our base must be bigger than 0 and our input must be bigger than 0. So x bigger than 0, y bigger than 0. So this is something that we want to remember. The first equation really doesn't give me a lot of information to work with. So let's just work with the second information. And this tells me that x cubed is equal to y. Now I can substitute y is equal to x cubed in the first equation. And I get x to the power 4 is equal to 81. And if you solve this, you get plus or minus 3. Because 81 is 3 to the power 4, and when you take the 4th root, because it's an even power, then you get plus or minus 3. Minus 3 to the power 4 is also going to be 81. However, because x is bigger than 0, then negative 3 is not a valid solution. So you only take x is equal to positive 3. And if x is equal to positive 3, y has to be 27. So your answer is 27 and 3. For part B, from this part, we know that y is bigger than 0. From this, we know that x is bigger than 0. So we only want positive solutions. So just to remember, x bigger than 0, y bigger than 0. Here and here. So now that we have that, we can simplify. Log base 10 y cubed. Putting this here gives me log base 10 2 times x is 2x. So we know that 2x is equal to y cubed. So this is what we get from our second equation. And from our first equation, we know that 4 to the power x is equal to 2y. So I know that 4 is just 2 to the power 2x, right? 2 squared x is equal to 2 to the power y. And therefore, we have 2 to the power 2x is equal to 2 to the power y. And we can, because the bases are the same, we can compare the exponents. So 2x has to be equal to y. So we know that 2x is equal to y cubed and 2x is equal to y. So we can say that y is equal to y cubed. I'm just substituting y here. And we know that y minus y cubed is going to be 0. So y minus 1 minus y squared, if I factor out to y, gives me 0. And therefore, y is equal to 0 is a solution, y is equal to 1 is a solution, y is equal to negative 1 is a solution, right? However, we said that y has to be bigger than 0. So this is not a valid solution and this is not a valid solution. The only valid solution is y equal to 1. And if y is equal to 1, x is equal to 1 by 2. So we only have one solution for B. Question 6c tells us to solve the simultaneous equations. And so the first equation, now what we need to know, we have some conditions. My x must be bigger than 0, which I get from this. My x minus y must be bigger than 0, which I get from this. And my x plus y plus 9 must be bigger than 0, which I get from this. So that is very important to remember. Now we can go on about our usual process of simplification. 4 raised to the power 0 is going to give me x plus y plus 9. So 1 is equal to x plus y plus 9. And x plus y is negative 8. So that is what I get from my second equation. From my first equation, I can see that x minus y log base 4 x minus y is equal to log base 4 x squared, if I put this as the exponent. So x minus y is equal to x squared. And actually, I can compare these two equations together. So if I add these two equations, x plus x gives me 2x minus x plus y, and minus y plus y gives me 0. So I don't have to worry about it. And I get x squared minus 8. So x squared minus 2x minus 8 is equal to 0. And therefore, x minus 4 plus 2 equal to 0. So this is how you can factorize, but you can also use the quadratic formula. Plus 2x minus 4x, that's minus 2x minus 8 is equal to 0. So x is 4 or x is negative 2. But remember, we said that x is greater than 0. So this is not valid. So we use x is equal to 4. And if x is equal to 4, y is equal to negative 12. So that should be our solution. And let's just check our conditions. If x is 4, 4 minus of minus 12, that's 16, is bigger than 0. So this is satisfied, this is satisfied. And x plus y plus 9 must be bigger than 0. So x is 4, plus minus 12 is minus 8, plus 9 is plus 1 is bigger than 0. So this works as well. So for C, the answer is x is equal to 4, y is equal to negative 12. And for D, we want x bigger than 0 from this part, we want y bigger than 0 from this part, and we want 2x minus 17y bigger than 0 from the third part. So let's just start solving. Log base 10x is equal to log base 10 y squared, putting the exponents on top of y. So this gives me x is equal to y squared. If I put both of my exponents, this side simplifies to x, this side simplifies to y squared. So I have x is equal to y squared. That is equation 1. And my second equation tells me that 10 squared is equal to 2x minus 17y. So that's 100 is equal to 2x minus 17y. And x is equal to y squared. So 100 is 2y squared minus 17y. So 2y squared minus 17y minus 100 is equal to 0. And we are going to solve this. So using the quadratic equation, y is equal to 17 plus or minus 17 squared minus 4 times 2 times negative 100. All over 2 times 2 is 4. So this is 17 plus or minus. So 17 squared minus 4 times 2 times negative 100 is 1089. And the square root of 1089 is 33 divided by 4. So 17 plus 33 divided by 4. So y is either 12.5 or y is 17 minus 33 divided by 4 is negative 4. But can y be negative? Well, no, because we said y is greater than 0. So we have to, this is not a solution. So y is 12.5, x is equal to 12.5 squared. So that is our solution. And let me just check the answer for you. So y is, 12.5 is also 25 by 2, and then that is just 25 by 2 squared. So this is the solution. And now we've reached the